In this video we're going to work out the limit of this function. So let's consider along x equals 0. So this is your domain. X equals 0 is along here. So when x equals 0, we can put 0 into here. So sine of 0 would be 0, and then put 0 into here. That would just leave you with y squared. The limit of this, but by the way, this is not really 0 over 0, because back to our 2D graph. Let's say a graph y equals x. Y equals x over x will look like this. 1 divided by 1 is 1, 2 divided by 2 is 1, 3 divided by 3 is 1. So when you plot it, it will look like this. Undefined, dead on 0. So when I give you y equals 0 over x, well, 0 divided by 1 is 0, 0 divided by 2 is 0, 0 divided by 3, and so on. It will look like this. So as you approach 0, as y approaches 0, you can see that you're heading towards 0. So the limit of this is actually 0, and along y equals 0, which will be this plane here, put 0 into here. Sine of 0 would be 0. Put 0 into here. This thing disappears, leaving you with x squared. Well, the limit of this will be 0. So we suspect our limit is 0. So now let's use the squeeze theorem. So if the limit truly exists, then this thing, take away our suspected limit, must equal 0 when you take the absolute as you take the limit as x, y tends to 0. This quantity must equal 0 because this is our suspected limit. So, well, when you have something take away 0, that's pretty much the same thing. But the thing is, when you take the absolute value of something, we know it's going to be greater or equal to 0. So we are currently here. The trick is to trap this thing in between two things, one thing and the other thing. Well, the next trick is to realize that that sine of something, you have to realize that sine of x is less than or equal to x, because if you look at the graph sine of x, it looks like this. Look at the graph y equals x, it looks like this. This y equals x graph will always be greater or equal to sine of x. And the reason you can tell is if you look at the gradient of this, is always 1. If you look at the gradient of this graph, well, dy by dx equals cos of x, and cos of x is always less than or equal to 1. So you know that this thing here will always be greater or equal to sine of x. So looking at this, see this thing here, if you can make the numerator to be bigger, so this thing here must be, hang on, let me think, x y squared and then squared plus, well, you see this thing here is always greater or equal to this block here. So from here we can take that step and take us to here, because this block here, you know, is going to be bigger or equal to this block here. It's going to be big. So we are currently here at the moment. Now this thing here is a positive quantity, this is a positive quantity, this is a positive quantity. So we can rewrite this absolute value thing as this, because this thing here is the same as this. Hang on. And then you can just drag this thing out here, so that will then give you this. Well, now you've got one block multiplying with another block. Well, this block here is always less than or equal to 1, because let's say 10 over 10, and then here if you have this is a positive quantity. If I put a 1 in here, then you know that this is a fraction. This is slightly less than 1. Well, anyway, we are currently here, so we know that this is slightly less than 1. So So that will mean that this thing here will be bigger or equal to this thing here. We know that this thing is bigger or equal to this thing here, because this is slightly less than 1. Well, this thing here is slightly bigger than this thing here. So now we are currently here. So now take the limit of everything. Take the limit of this, take the limit of this, take the limit of this. That will then take us to here. And then take the limit of this as xy tends to 0. The limit of this will actually be 0. The limit of this, because it looks like this, well, the limit of this will actually be 0. So we don't know what this limit is doing, but we do know that it's trapped in between 0 and 0. Therefore, by the squeeze theorem, the limit of this must be 0. Okay, so this is our final answer.